The urban population produces more than 1 tonne of garbage per person a year. This is several million tonnes of household and municipal waste per year in every city in Australia and every other country. We decided to make a fuel similar to diesel fuel oil from these types of waste, and now we will show you how to do it. Our team of specialists solved this problem using the method of low temperature pyrolysis, thermal destruction of molecular ties without the access of oxygen in a controlled environment. Scientific work of our group was devoted to developing an innovative technology and equipment for practical use in the processing of industrial and domestic hydrocarbons containing wastes. Our chief engineer and inventor has recently been awarded a PhD for his pyrolysis thermodynamics research and registered several patents. Normally, what do we have in an ordinary garbage bin? Plastics, plastic bags. We have pieces of wood, paper, Tetra Pak cartons, food leftovers, plastic bottles, cups, lids, other household rubbish. From all these we can make a quality fuel. There is a number of difficulties and technological challenges in the pyrolysis processing of the solid municipal waste and household garbage, especially when it is mixed with plastics. We managed to solve these difficulties and problems by regularly modernising our laboratory facilities and pulsar unit. This is a pilot industrial experimental installation where all technological cycles are worked out. Everything we saw close up in the garbage bin is already cut, crushed and shredded here. This is what we will process now. This gives us the opportunity to apply a cheaper method of producing motor fuel, similar to the diesel fuel quality, because there are very few resins left thereafter, 95 to 99% less. This technology will be of great benefit to local councils and solid municipal waste processing companies, to the household garbage sorting depots, where waste and garbage are collected, sorted and stored in great quantities and of different composition but are barely recycled. The gas temperature before the filter of the condenser block is now 393 degrees. After the filter, the gas temperature drops to 63 degrees Celsius. Due to this temperature imbalance, a shock system of filtration and condensation of pyrolysis gas is possible. This way we remove 95 to 99% of the resins. We have now a light fraction, liquid hydrocarbons. This is a raw material for fuel. The second fraction from the solid municipal waste is paraffin or oil sludge. They are mixed with the light fraction. This usually prevents pyrolysis plants from working normally, but this is exactly what provides an extra energy to the fuel. People don't know what to do with the paraffins, but this is a tremendous energy potential for a motor fuel. We now test the two fuel fractions for flammability. From these two combustible components we can make motor fuel. We have tested the characteristics of 4 groups of fluids obtained by pyrolysis, and all 4 cases we had recommendations for 100% use as motor fuel. This liquid is a suitable fuel and has been tested in the heating and power plants in lieu of diesel fuel. There is a scope for special applied chemistry for the fuel additives manufacturing. We created our own laboratory to test the performance of non-standard synthetic motor fuels derived from plastic waste. Using a 24 kilowatt diesel generator, we determine how well this new fuel is working and how it affects the characteristics of the engine and its fuel equipment. We use several interfaces to get the experimental data. On the computer panel, we see all the parameters of our experiment: the temperature of the exhaust gases, coolant liquid, outside air temperature, instantaneous fuel consumption, and total fuel consumption. All parameters are recorded in the cloud for further analysis, for trends and charting. The diesel generator ran on the new fuel perfectly. We now check the engine's fuel injectors. It is necessary to check the injection pumps and fuel nozzles for any deterioration in flow rate. The nozzles are tested for overflow, residue and for atomization of the new fuel, and for any damage. As the fuel comes out, it produces dark spots on the jar. The new fuel doesn't affect the tightness of the nozzle atomizer and of the needle seat, nor the fuel atomization quality. The pressure response was the same for all cylinders, indicating that all injectors have passed the test with the new fuel. After the test, all parameters of the fuel equipment were within the tolerance limits. The fuel equipment and engine were not damaged. After processing city waste containing plastics, we found the following components in percentage ratio by weight: 27.7% light fuel fraction, 18.6% heavy fuel fraction. This constitutes an effective gross yield of about 46.3% of the weight of recycled garbage. The remainder is pyrolysis gas containing ethane, methane, butane, etc. Pyrolysis gases are almost 100% utilised and burned inside the furnace unit during the process, reducing running costs. In conclusion, the processing of household garbage and solid municipal waste into motor fuel is extremely cost-effective and energy efficient. Municipal solid waste can not only be burned or buried in a tip, but it can and must be recycled and made into useful products. And this is not only about the fuel. There are still a number of aromatic hydrocarbons. They can be synthesised into a lot of useful products that are in demand in petrochemical industry as well as in the fuel industry. We can safely use this synthetic fuel for continuous production of electricity, for heating water, and use this new motor fuel for agricultural machinery and tractors. Our industrial plants can process a colossal number of about 160 types of various wastes. We can process with a high degree of efficiency and produce motor fuel or electricity from the garbage and waste of various plastics, old car tyres and rubber, from scrapped automobile plastics and plastic computer shells, from the remnants of varnishes and paints, from used car oil filters, wood pieces, offcuts and sawdust, from old synthetic carpets, soil from oil product spills, even from animal droppings waste from pigsties and poultry farms. All these installations will be different in configuration, different in level of automation, but all of them will have a high energy and economic efficiency. Pyrolysis technology is old, our innovative solutions new. The three-stage principle of filtration and complete utilisation of pyrolysis gases, almost complete removal of resins and strict control of the exhaust gases into the atmosphere to a level that meets the latest international environmental agreements. Our technologies and industrial waste-to-energy mini-plants are used in Europe, China, South Korea, India, Vietnam, Russia and the USA. Exclusive rights to use this proprietary technology and equipment in Australia, New Zealand, Southeast Asia and Oceania granted to Crisis Relief Foundation Limited. We are open to cooperation with all private and public enterprises, government agencies. We welcome your inquiries.